This project actually won the Best Abstract in 2016 in this conference and was presented by Matthew Komorowski last year. And briefly, this project used reinforcement learning, which is the methodology behind the AlphaGo software that beat a human expert on the board game Go. And we use this to optimize how we treat hypotension in the intensive care unit. So we were able to find the best doses of fluids as well as vasopressors when we optimize the algorithm to increase the chances of survival at 90 days. In all the high-impact journals, we've seen lots of perspective pieces. In JAMA, every month there will be an editorial about machine learning and AI. I just wanted to highlight an editorial that was written by Jeff Hinton, who is one of the pioneers of AI, appearing in JAMA. In January, there will be a special issue of Nature Medicine on machine learning in healthcare. And then JAMA Network Open just released a call for contributions for what else? Machine learning in healthcare. I wanted to, I put in the last citation there just because I think it's a preview of the next best thing, which is causal inference. Last week, we saw the engagement of causal inference with data science during the NIPS conference. As you know, NIPS is the biggest machine learning conference, and the keynote speaker for NIPS this year is Miguel Hernan, who is one of the biggest names in causal inference. Why is this important? Well, machine learning would optimize based on associations that are inherent in the underlying data, but sometimes those associations are spurious. They are dependent on associations that are provided by backdoor pathway that is given by some unmeasured variable or variables. And we think that the introduction of really of causal inference into data science, into machine learning, would be the next big event in the field of artificial intelligence in healthcare. This is a follow-up to what Anthony said earlier, that you actually don't need deep learning to really take advantage of some of the data that we are collecting in the process of care. This is a paper that we published in JAMA Network, where what we did was we tried to provide a bit more relevance in terms of the interpretation of laboratory results in the ICU. As you know, the current standard now is that we are given a reference range based on 200 normal people out there. So that's how we determine the reference values for labs. And we argued in this paper that that population is completely irrelevant to the population that we're taking care of in the intensive care unit. And for this paper, all we did was we looked at the cohort of patients who had the best outcome in the ICU and the cohort of the patients who had the worst outcome in the ICU. So the patients who died and the patients who had the shortest length of stay in the ICU. And we provided a distribution of the different labs that we collect in the ICU, and we showed how that is different from the reference range. And instead of just giving us the reference range based on 200 healthy people, what we could do is to give you a probability of the different outcomes that you're interested in when you're looking at a certain lab. And at the right upper hand corner, we decided to focus on an outcome that's even more relevant than mortality, for example. Here we were looking at serum potassium, which is one laboratory result that we repeatedly check in the lab. I would say that 10 to 20% of our time in the ICU is checking and repeating potassium. And we have this cutoff of 4 that we think is the goal cutoff. And here we looked at what is the probability that an arrhythmia would occur an hour before or an hour after a serum potassium determination to see the real risk involved with that particular value. And what we found is that in the medical ICU, you don't see any increased risk of arrhythmia until the values go down below 3. So the point here is that we could do this for every laboratory test. We could find out very individualized cutoffs that would be more relevant to the population that you're taking care of. What we decided as a panel today is to focus on what are the issues that we think would be challenges in moving the field of AI for decision support forward. And I'm going to start off with reproducibility issues. So last month, PLOS had a special issue on machine learning in healthcare, and I was one of the guest editors for this special issue. And we decided to focus on reproducibility as really the emphasis of the special issue. And we are concerned because every week we hear of claims of superior algorithms that would predict clinical events or trajectory of the disease, that would translate text, clinical text, and that would recognize images. And we're also inundated by all these novel discoveries of risk factors for diseases, as well as determinants of treatment responsiveness. And we're concerned that since there is so much hype around machine learning and AI that is usually followed by a lot of funding, and then there is increasing availability of data, that we will be soon facing a tsunami of irreproducible research. So that what we said is that this will be the main theme of our special issue. We are going to outright reject papers where they would fail to share their anonymized data, and they would also fail to share their codes and queries. And initially, we were concerned that we would not be left with any manuscripts, but we're happy to announce that we have an amazing collection of papers where they were happy to share their anonymized data, accompanied by their own Jupyter notebooks as well as GitHub repositories. I'm going to pass on the microphone now to one of our panelists to continue with another issue as a barrier to AI for decision support. Thanks.
Thank you, Leo. My name is Randall Wetzel. I am a pediatrician and anesthesiologist at Children's Hospital Los Angeles, and you may wonder what I have to do with that, or what that has to do with this, but we're talking about applications of AI in critical care. I just want to touch on why pediatric critical care. Pediatric critical care is really much better organized than adult critical care. We have pediatric intensivists that run the ICUs instead of a host of other specialists. We have national organizations focusing on research and data aggregation and collection. We have a database that has 130 ICUs contributing over 1.5 million patients to it. Obviously, the outcomes of pediatric critical care are important to children and therefore to society. It's a wonderful lab. We have high volume, high velocity, high variety of detailed observational data. The outcomes are known over a short period of time. If you're studying diabetes, blindness is terminal 20 years down the line. In the ICU, we know in a few days whether you survived to leave the ICU and how well you were when you left it. So we really have a great test bed for testing out artificial intelligence and machine learning algorithms that are predictive. We have an advanced IT infrastructure in our hospitals. We're highly digitized and structured data. And the findings that we develop are applicable across healthcare. Well, I wanted to talk about data. We are obviously data. Our patients are data. And in this picture in the second panel down on the left, that's where one of my patients is. All of that technology is generating data. Leo wanted me to talk about data, and data as a commodity is always a concern for us. I think that the competition and profit motive in managing data is something that all of us have to resist. I think that data yearn to be free. The information is really a public good that we need to use to learn about how critical illness happens to our patients, and we need to overcome a lot of political and financial and institutional barriers to keep sharing that data that all of us need to be mindful of. Yes, it's valuable data, but its major value is in what it can teach us about our patients. How can we liberate the data for a better world? Well, that's all of our jobs that we have to do, and we have to resist payment for datathons. We have to resist selling our data for profit. It's much better to have the data that we can sell what we learn from the data. And as I mentioned, is healthcare data a public good or a private matter? Well, obviously, we don't want our data everywhere. And I have to say, HIPAA, which has been around for 15, 17 years, has actually been good for us. Had we not had regulations, the Wild West would have gotten even worse regulations, as indeed has happened to our European colleagues with the fun GDPR, the EU's General Data Protection Regulations, which have really pretty much made it impossible to access healthcare data and to share healthcare data among investigators and institutions without an awful lot of bureaucratic regulation. We may be headed that way. Our HIPAA regulations are probably out of date, and probably a little lax, and we need to figure out how we're going to carry on doing this sort of research. And I just want to mention this terrible word, which is all they talk about in Europe these days, synthetic data. Because synthetic data, of course, doesn't belong to anybody. You can do research on it, but it is, after all, synthetic data. And if you want to understand synthetic data a little bit better, you can read the panel down at the bottom about how data that is really quite faithful to the data from which it's derived and is quite worthwhile and useful for doing machine learning. So a few other issues. Our data pipeline is the bottom panel. We get data from lots of places, but unfortunately, every source of data has a disparate data model. And homogenizing and uniformizing those data models into something that we can apply machine learning and AI to is always a challenge. And of course, healthcare data, although we have a lot of data in critical care, it is irregularly sampled. The sampling frequency itself can tell you something about the illness in the child, but it's irregularly sampled. We may have heart rates every 5 milliseconds and serum potassiums every 5 hours, and some measurements only every other day. So trying those, that's not ideal data for machine learning, and picking the right approach and managing the data appropriately is often not discussed in a lot of papers. The data is, in classic machine learning techniques, sparse. Monitor data is quite good. However, EHR data is sparse. Hour samples, measurements that are, from a machine learning perspective, pretty infrequent. There's obviously structured and unstructured data, and the data is stored in places geographically separate. That may not sound like much, but our EHR data in Los Angeles is actually stored in a database in Kansas City. And we have other data that's in the Amazon cloud, and we have other data that's in our, God forbid, our data center in our hospital. All of those don't sound like a technology challenge, and they aren't. They're political challenges, and they're firewalls in between all of those places with people controlling the data flow. And getting the data into one good place to analyze is challenging. There are, thank goodness, some standards. I would have before said there were none, but there is certainly a growing standardization move. I don't know what you think about HL7 FHIR, but it is at least a national standard. And talking about data quality, the first thing to think about is, do we have data that's relevant to the question we might want to answer? And is the data suitable and relevant for answering those? Uh-oh, that doesn't look good. Does data quality matter? Everybody would put their hand up and say yes. Now, I'd really love to have the time to ask you all what you mean by data quality, because does that mean its validity? Does that mean its applicability? Does that mean its missingness? Does that mean whether the data set you have is complete and has all the little cells in your matrix filled out? When you read papers that have used medical data for machine learning, do they tell you what the missingness was? Do they tell you how much interpolation or extrapolation or guesswork they have done to fill out a data matrix that's suitable? Or are they using a machine learning technique that can manage the missingness? Those are all important points. Noise. What is noise? Well, duplicate numbers, numbers that are clearly erroneous and not possible, and anything that we think doesn't contribute. They could even be extraneous features that just happen to be in the data set. Are you selecting algorithms and machine learning approaches that can deal with that? As an example, in the second panel down on the right, we looked at, noise is the third panel down from the right. We looked at adding features that we knew did not contribute to the outcome. And it doesn't really matter what we're looking at, it's discrimination. By adding features that were non-contributory, using a recurrent neural network with an LSTM architecture, that the noise that we added did not actually affect the discrimination of our outcomes. And it didn't matter whether we were looking at mortality or trying to predict physiologic states, future physiologic states in patients in the ICU today. That using the right algorithms and constructing them correctly can actually make the noise less of a problem than you might think it is. And there's a lot of noise in clinical data. Quantity, how much data do we have? Can you apply machine learning algorithms to 50 patients or 50 episodes of ICU care and expect them to be generalizable and reproducible or not? That second panel was looking at 3 machine learning algorithms, just to say this, MLP, multilayer perceptrons, another RNN, and logistic regression, and then decimated the data down, the amount of data that was available. The discrimination stayed quite good, even down to 10% of the data. That 10% of the data, however, instead of being 8,000 patients, was still 800 patients. When we went down to 80 patients, most of this fell apart. So the amount of data that's analyzed, you can find lots of machine learning papers doing 10, 20, 30, 40 patients. The other thing is the generalizability that second panel also shows. The algorithm, again, an RNN, was developed in general pediatric ICU patients. That sort of second level down with AUCs of about 0.8 was actually the same algorithms applied to cardiac critical care pediatric patients. You can see its discrimination fell from 0.95 to 0.8. Same, not the same ICUs beside each other, when both at CHLA. But developing the algorithms in one population that was critically ill children was not applicable to a population cared for concurrently right next door. So another thing to consider when you're thinking about the generalizability. Leo said something this morning about continuous need for recalibration of our algorithms. That has to be continuous. We're working on automating that continuous. As the data comes in, the algorithms are updated before they're applied. And that's setting that to the bedside. I have garbage in, garbage out down there to say, well, there's a lot of garbage in clinical data, and we have to be able to design algorithms that can deal with that garbage, because cleaning it and finding it is not all that easy. I want to mention DocDat, if anybody knows what that means. A paper by Black 15 years ago in 2003 explained a British system for defining the quality of databases and building a database registry so that we could see the quality. It's a great idea. Set up standards, 10 standards for assessing the quality of databases for us to share. I don't think that's caught on, but I think that we need to think about some way of defining and describing our databases so we know if they're available. Suitability for the research being done, we've mentioned. Generalizability, I've also given the example of. Reproducibility, Leo mentioned. Now, quality, I usually think of validity, completeness of the data, and accuracy of the data. But all of these other elements are also important in trying to understand and describe the quality of the data we have to learn about our patients. Thank you very much. Do you want to blind people?
Yeah. Oops, sorry. Let me go back one. It was already there. Well, good afternoon, all. I'm probably the least qualified of my esteemed colleagues here to be up here talking about this, but I appreciate the opportunity to get to speak for a few minutes. I think the unique perspective that I bring to some of these conversations is really where we've seen the application of these technologies that we're talking about. And I've been involved in the evolution of the discussions at the more strategic level with hundreds of hospitals and different clinical settings across the country. And it's really neat to be part of this, to really see how these conversations, again, have evolved. I'm sure many of us can remember not that long ago, there's lots of these neat conferences and meetings that have been popping up over the years. But the conversations have shifted quite a bit to kind of this theoretical, this hypothetical, wouldn't this be cool, this technology is really neat, and we sometimes get into the weeds of the math behind a lot of this. But you know, we're at a place in the industry where we can actually apply these now, and that we have seen time and time again the success that can be applied. We sometimes get, you know, lost in that analysis paralysis, saying, well, we have to address these barriers, certainly, but to really see how now the technology can really produce certain results from at the patient level, we need to start actioning on them. And so a couple of the other barriers that we had talked about were things like, formalizing assessments prior to models being turned on in certain care settings, and obviously, and Randall touched on the recalibration need of these models. All very, very important, but there's technologies that allow us to overcome a lot of the frustration or the concerns there. We're using an eigen-based mathematics approach that really allows you to, point the technology to really any adverse outcome that you're wanting to look at. That really addresses the need to have to rebuild a model every single time you want to look at an adverse outcome. Same thing with having to recalibrate every time a new data source is ingested into certain technologies to say, well, now what's it going to do to the outcomes? What's it going to do to ultimately the results that you're trying to achieve? And so for us, it's really pretty neat that we get to see how this has all kind of come full circle, where now you can put these technologies in action, and again start to really see some powerful results to overcome the frustrations that we see with that traditional model building and the traditional kind of analytic and building processes. So I think hopefully just for a little kind of background, hopefully that's okay, and we'll pass on to our next kind of barrier of entry that we wanted to touch on.
Our final barrier.
I am the final barrier.
The final barrier of the day.
So kids like dressing up, and I think that that's a great analogy for some of the things that I do. So some days when I'm dressing and I'm wearing a certain hat, I'm the chief medical officer for a startup up in Palo Alto that works on neurobehavioral precision health using AI. Sometimes I'm the division chief of neurology. And in that, though, I also have the opportunity to be able to mentor through a summer internship program and expose a number of high school graduate and undergraduate students to artificial intelligence in medicine and innovation in medicine. I also wear a clinical informatics hat at Chalk and help implement the EMR and partner with our vendor, which is Cerner, and have great relationships with our data scientists and our informatics group and our innovation group to try and figure out how to work on projects like the ICU projects that we're working on. And then I also wear another hat over at the university where I am the site director for the Clinical Informatics Fellowship. And so what we were kind of discussing as a panel is when we start thinking about what are the barriers to really implement these things in a clinical setting, and what does that future look like for us, it really is getting those new coming physicians, those graduate students, those high school students that are going to be the next generation of physicians, and the current medical students and the current residents really having a better familiarity of clinical informatics, of artificial intelligence in medicine. Most of us up here and most of the clinicians in the audience may have not had formal training, maybe with the exception of Anthony, who went out and actually got some formal training and got his master's in computer science. Many of us are actually self-taught, kind of learned on the job. And although we can use that expertise, having clinical programs in place to actually teach is important. Anthony and Leo talked about many of the publications that we saw in the past year. And so if you throw machine learning into PubMed and you look at how many articles this year came up, if you had to take a guess, what would you guess? How many? Whoops, that's backwards. We'll go forwards. So it was 5,310. So it's actually a lot, right? That's a lot of publications. I did not read all 5,000 of those journals, and I don't know what the quality of all of them are. But there are some really high quality medical publications on machine learning. The interesting thing, though, is if you add a qualifier to that and you say, you know what, let me look at machine learning and medical education. How many do you think came up? 49. But if you actually look through, and I did look through all 49 of those because that was a more manageable task and I didn't have to use an AI, there's actually only 2 that were actually relevant to real medical education of training physicians about machine learning. The remainder were actually about patient education and using machine learning for things like patient education. So there is a discrepancy here. You have this exponentially increasing field of medicine, which is involving AI, but there's this disconnect between the medical education system and how we train and teach the residents. If you think about it, we only have about 30 clinical informatic fellowships in the country, in the United States, and there's only really 2 AI and medicine fellowships, one in UK, which is Babylon, and one in the US, which is the Google Fellowship that I'm aware of. And so there's a discrepancy. And so I guess my thought about how do we make this better in the future and how do we take on a lot of the challenges that the group has talked about, and even in Kevin's keynote this morning about how do we create systems that actually work for us, right? Because these are the people that are going to go on and become the CIO or the CMIO or the CHIO of the organization that you work with. They have to understand machine learning and they have to understand clinical informatics. And we can't just do it at a fellowship level. It has to be embedded within the curriculum starting on day 1 of medical school. So my play is that it should be incorporated throughout the curriculum. And really, that allows us as clinicians to be armed for the future of this artificial intelligence in medicine revolution and movement that is happening.
So we now open the floor to questions from the audience.
And maybe while we're waiting, I actually had a question for Randall while he was talking.
I'm sorry, you do.
You missed your window.
So he had talked about this reiterative process by which in the ICU we are leveraging a retraining of the algorithm as new data comes in. And I think maybe as a group we can talk about what are the challenges with that specifically in terms of what is your confidence level of making that switch? And do you have, because a lot of times when we think about artificial intelligence and our algorithms, it's lock them down, validate, and then retest, and then when do you flip the switch?
Well, I guess I'll talk about why I'm interested in this. And about 15 years ago, this national organization that collects data from all these pediatric ICUs applies severity of illness scoring to them. And we noticed that our severity of illness scoring was drifting. I don't want to get too detailed, but a standardized mortality ratio should be 1 for a huge population, and everybody was falling below 1. It was no longer accurate. It had drifted because care had improved or because the data had changed or whatever. And so then we realized we had to routinely, regularly recalibrate. And this is just logistic regression analysis of a bunch of factors to determine severity of illness. When we started doing machine learning on same but more granular data, we noticed that even within 2 years, the applicability to a down the line 2-year population, there'd been some drift in the calibration. Recalibrating it would give us better outcome predictions in individual patients. So care changes, observations change, the data changes, and I think the need to continue to make sure that we're applying to the next patient, not just the previous 10,000 patients, but the next patient requires us to be always aware of that situation and therefore always recalibrating. I've said enough, although I do want to say this gets to be a tautology after a while. We're changing care. We might even be recommending care, and then we're testing to see if our recommended care was the right care, maybe using the same algorithms. There's a leakage problem, there's a tautology, there are issues that we need to be cognizant of.
So I'll add another level of complexity there. I mean, our definitions of concepts are changing all the time. So if you had an algorithm that would try to predict the onset of sepsis, and 5 years ago the definition of sepsis is different from now, how do you recalibrate that? Hypertension. Before, the cutoff for hypertension is 140/90. Now it's 120/80. So how do you do the recalibration when the definitions are actually changing all the time too? And we don't have easy answers for those questions.
Well, maybe we shouldn't call it recalibration. Maybe we know that we have to continue to develop timely, concurrent, predictive algorithms all the time.
Yep. Okay. The challenge is how I mean, I think medical education as a society is still very hierarchical and very old-fashioned. How do you convince the leadership at the top that there needs to be a change, a transition in the way we're teaching our next generation of clinicians?
Great, thank you. There's another question back here.
Hi, Frederick Wagner. Nice discussion, thank you. Clearly in this panel, as well as throughout the day, kind of a theme is that the quality collection and curation of data is critical and requires a lot of effort. And it also seems that many different institutions have kind of, my impression is that they maybe have had to reinvent the wheel. So I was just wondering if you could comment on the emergence of any standards beyond HL7 FHIR that might help with that.
I won't talk about standards, but maybe we could talk about what are some accessible databases that exist. I think, you know, Leo has Mimic 3, that's his baby. The one that I play in is something called HealthFacts, which is from Cerner. It's about like 600 different sites, and there's like 160 million patients over 16 years. But even then, the data within there sometimes is not always helpful, right? Like if you're trying to figure out where the patient got discharged from, you don't know the location necessarily. You know that they were maybe in the ICU, but you don't know if they were discharged from the ICU versus the floor. For example, turned out to be one of the questions that we couldn't query, even though we had access to that large database.
You're hearing silence about standards. We all.
I thought I diverted that question
you
totally
tried to.
sideways. Why are you bringing it back?
I felt sorry he was going to go away with no answer, because there isn't really a very good answer to this. And in fact, we have forces working against standardization. You know, it gets back to that first question on my slide: data as a commodity. If you think data is valuable and you're not going to share it because your possession of it, oh gee, let's see, Cerner Epic, is valuable and they should pay, the people who generated the data should pay you to get at their own data, then you don't want standards. You don't want to be forced to have interchangeability between your data set and somebody else's data set. And you're certainly not going to spend any money or participate unless the industry gets together and sets industry standards. It ain't going to happen. And unless they are incentivized in some way, either by external compulsion or they see there's money in it, they're not going to actually voluntarily spend their money to open up their data sources. I may be a little cynical about that. I'm hoping Leo can be more optimistic.
Yeah, no, I don't think there are any shortcuts when it comes to curation. And I don't think standards would actually make curation easier. Curation has to be done by the people who are actually familiar with where the data came from. So I remember I was in a conference and they were saying that the US is falling far behind China. Baidu is hiring 50,000 medical students to curate their data. And I was thinking, in all due respect, I don't think medical students could actually curate medical data because they don't understand the operations. They have not been exposed yet. And you will need people who actually work in those hospitals to curate the data for you. And there's just no way you could do it very quickly or apply even AI to curate your data.
I think the only thing I would say is, and again, and this maybe goes back to what I was asked to talk about, which is if we train a next generation of clinicians who are applying these things, right, prospectively, it's much easier to collect data prospectively than to say, I'm going to go back and try and obtain this data, right? So I think this is where, if we're in our institutions, if we're in our organizations, we should start thinking about, how do I set this up in a way that is AI friendly? And I think in the morning session, we talked about one of the hospitals in China not even having a medical record, and how that's actually maybe a really good thing, because when we set it up, we can set it up in a way that actually allows us to be successful and productive when we move forward and collect and curate the data.
While we're waiting, I will say that independent efforts to bring data from disparate data sources together for the community to share are worthwhile, and if they move on, they will set the standards. We are sponsoring a PICU data collaborative, asking for EHR data from volunteers to send it. We have a data repository, And the purpose of doing this, if you send your data, then you have access to the whole database. So if you get 10,000 patients from 10 hospitals, instead of you working on your 10,000, we have standards within that database that you now have 100,000 patients that you can use for machine learning. That was what was in the top right-hand corner of my slide, but if you go to vpicu.net and look around for programs, you might find how to participate in that. But to start efforts, I fortunately have a grant to do that, so providing that it's not a cheap undertaking, but we've got the architecture and the cloud instantiation, and it's ready to receive data, but then getting data in the right format and the curation is challenging. But I think that'll I think ultimately, when you have 20 different people who are playing by the same standard, since there aren't any now, that's still a better standard than we currently have.
I'll just add though real quick for that, one of the things that the challenge is outside of, not wanting to share your data because you want to monetize it or something like that, you talked a little bit about the regulatory challenges, right? And so I was having this conversation with Arda from Alignment Healthcare, what are the challenges of, what is your liability of exposing data that, given the tools that we have now, can be maybe de-anonymized, and what liability does that open your institution up to, and what are the barriers to actually allow for people to be more willing to share their data? And I think one of the things that we talked about last year at the AI Med conference was how do we actually get the data to the patients and allow the patients to then decide whether or not they own the data, which they do, and how do they then share the data in a secure way, maybe using something like blockchain. And I think we need to start setting up those systems, and at a higher policy level, we need to start pushing policymakers to enable patients to have all their data in a format that then is shareable and with some standards that actually work to create databases for clinicians and empower the patients to be part of this solution as well. So like we said in the very morning session too, right? I can't remember her name, but the young lady with muscular dystrophy said, I need to be educated about AI as well. So I think that education is for us also not in the medical community, but for the people that we're serving.
Jay Nahar from Washington, D.C., pediatric cardiologist. A question is actually like how we have cognitive biases when our algorithms become much smarter. How do we safeguard against the algorithmic biases as we go forward?
So, algorithmic bias is a real phenomenon. It's something that we're paranoid about. And what we do every time we come up with an algorithm is to make sure that it's performing consistently across different groups. So there's the paranoia that certain groups that are not represented well in the original training cohort, the algorithm is not going to perform as accurately to them. And there have been several examples of algorithmic bias, not just in healthcare, but also in other fields. But one example that I could think of would be the application of illness severity scores for morbidly obese patients. And we know about the obesity paradox, where morbidly obese patients actually have better outcomes in the ICU, which clearly there's something wrong there, because if that's the case, they should be living to 100 or 110, but we know that that's not the case. And our hypothesis is that they could be gaming the system. At baseline, their vital signs are already off, so that when they come in, they may look very ill based on our cutoffs, because there were not a lot of morbidly obese patients in the original training cohort when they built Apache. And it's for that reason it's not really performing well, and it's not really giving you a good sense of how sick they are when they come to the ICU and you start applying those algorithms. But algorithmic bias, I think, should be at the top of the list that we should be concerned about when we develop these algorithms and machine learning methodologies, that it should be performing consistently even among those groups of people who may not be represented in the original cohort. And then the other thing is that when does the clinician know that this algorithm really does not apply to the patient in front of me, so that you have to be really paranoid that this is not the right patient where I should just implement this particular machine learning methodology.
Yeah, I would echo that, and we talked a little bit about this in the cognitive computing workshop yesterday. Being aware of biases is extremely important, not only the algorithmic biases, but clinician biases as well. and how they can potentially creep in. So the awareness of it is I think the very first step in combating it. And then again, I'll just harp because I can. It's about education too. So if we make sure that we educate and that collaborative between the clinician and the data scientist helps that be a problem. Or not be a problem, I should say.
Any other questions from the audience?
I see one more maybe.
Hi, my name is Newsy. I'm actually a UX consultant. So my question has to do around kind of theory and design. And I don't know if it's a question, it's just kind of a thought. So I want your thoughts on that. So I'm hearing a lot about predictive analysis and determining chronic disease, but I'm wondering how the way in which we view medicine in general, the shift of that in terms of understanding the whole body. There's these terms like integrative medicine, functional medicine, understanding trauma within medicine. How does that play into the way we're thinking about AI? Because what if the way in which we view medicine changes, and it is changing? So how are we shifting to looking at the whole body rather than certain specialties or certain disparate systems?
I think it's more than just even, that it's changing to looking at the whole body, as you said, but it's also looking at what other determinants, social determinants, exogenous consideration, environmental, and considerations that make up that whole view, and then using all these techniques that we're talking about and different math and different sciences to be able to make clinical sense, clinical relevance out of illiteracy and food desert, insights, as well as someone's, physical makeup.
So, I think we would acknowledge upfront that the electronic health records are not complete in terms of representing the patient. As you pointed out, social determinants are not well captured in electronic health records. One way to address that would be, for example, there are creative ways of bringing in the social determinants of health. You could use the address. And as you know, every address in the United States, it's linked with so many data about social determinants. And you could start putting those into your models so that you could come up with a better representation of the patient.
What you were talking about actually got me thinking a little bit sidetracked. There's two things that came up. One is I think how we present the data, and I think you were kind of a little bit going there, Nuzi, I think that's extremely important, right? So how do you present the information that now we know to a clinician in a meaningful way with all the other information that they're getting kind of data tsunami on them? And then the second question actually that got me thinking is, we're talking about ICU and kind of critical care settings. These patients go home and they may come back. And what is after the PICU, after the NICU, after the CVICU, and they go, right? How do you guys think about maybe monitoring those things?
I've always talked about the need to include non-traditional sources of data. Behavior is a big predictor of outcomes. And that's nowhere captured in the electronic health records. And somehow that needs to be included in the models too. But again, if you start putting that all in one database, then the probability of re-identifying someone goes up exponentially. And this is now going into really weighing the risks and benefits of, do we need to know everything about the patient so that we could completely understand health and disease? And what are the downside of doing that, which is really now we're going to be giving up a lot of our privacy if we start putting in some of the other non-medical data into the modeling.
Well, we've got these deep learning technologies, though, that I think is great because now it allows us to even start to get those insights to understand, again, what is that correlation that you're using zip plus 4, as you say, one of those examples, and all of those relevant factors that come with those social data, behavioral data, and all of that. We need to be using these techniques, this machine learning and AI technologies to understand those correlations and how they do connect to clinical outcomes. And I think, again, this goes to the buy-in, adoption, how do clinicians feel about these technologies? When you really see something like overall impact, we've reduced whatever adverse outcome that you're looking at because we applied this and we're using social determinant data or clinical data in, as we look at a patient in kind of this holistic view, that's when I think the light bulb goes off for people going, yes, this is technology that really can truly drive impact.
Just to be a contrarian, one of the reasons I've restricted myself to pediatric critical care is we find out the outcomes. Do you get discharged from the ICU? How long you were there? Did you live? Did you die? Was your morbidity worse than it was when you came in? Those are outcomes I can see in a few days. Now, that's blind to, we do know that an ICU episode affects your health for years afterwards, and that there are outcomes that are different among populations. We also know that your nutritional status before you come to the ICU, not just obesity, has an impact, but we never assess that. And that's just one thing. I'm not sure that we are ready to jump into all the data in the world dumped into our AI algorithms. I think we are making inroads with the restricted information. We'll never have it all, but with the restricted data that we have, and we need to continue to demonstrate the validity of that before we try and boil the ocean. So that's my contrarian view here. Yes, I appreciate the question. It's been a question that health has dealt with, healthcare providers have dealt with since Hippocrates, that the social surroundings and social circumstances certainly have a big impact. And we have been bad for 4,000 years at really understanding that impact. We've become aware of it, but I'm not so sure that AI is ready to swallow that whale just yet. That's
we'll just keep doing it human to human.
We have one last quick question over here.
Just adding to what you mentioned about the patients after the ICU go back home, and you need to continue monitor if you don't want to be readmitted. So how you suggest this industry standard should be formed, because this is a necessary, this is a trend, and we have to come up with some initiate and some alliance from very good conference like AI Med, that how the medical community can suggest what should be the industry standard, because now 5G coming, and one of the vertical market is healthcare, digital health, and outpatient data. So we cannot avoid it's coming. So whatever we want to call it, we have to initiate alliances and form a standard group like what they do for the telecommunication. They have 5G standard, and they have so for this vertical market, we should have some alliances. And that is standard.
A very good question and a very good concept, but I'll be the naysayer on this one too. We can't get patients to take their medicine when they go home. You're going to now ask the patients to wear monitors or to check in frequently with the post-hospital episode or somewhere in their healthcare episode. I think we have a lot of challenges there, and we have to demonstrate that it's of value, just like we have to demonstrate it to the clinicians. We have to demonstrate to the patients that it's in their interest to do that. And that's going to take, I think, a bit of time. That's my be pessimistic.
You're so pessimistic. I'm so optimistic. So I actually see, yes, yay for optimism. So I see the patients actually wanting to take this home. I think there's a little bit of a security blanket there. I think we're seeing, especially, like we said earlier, there's an older generation that is embracing technology and willing to take that home with them. I think there's a younger group of patients that are also, digital natives and interacting with them through secure messaging or text messaging type things is something that's happening today, and remote patient monitoring is growing. I do agree that the value proposition is not yet there, but that data is coming. And one of the challenges is, what are you going to do with that data, right? I don't know what to do with some of that information that starts coming in. And I mean, in the quote unquote old days, right, I would have patients, I'm a neurologist, so I see kids with epilepsy, the parents would come in with a grid, and here's my seizure grid, right? But now if I have a feed and it's in real time, am I responsible at 2 o'clock in the morning when I'm sleeping that a feed came in that the patient had a seizure, or where's that response? So this is all going to change, right? Medicine is not static. You know, we talked about knowledge is not static. Healthcare monitoring outside of our traditional healthcare settings is not static. This is all evolving very rapidly, and ultimately we're going to have to figure out how do we figure out what the value proposition is, and where do we invest in? Because the other thing is that, and here I'll be a pessimist.
Oh, no.
The healthcare costs are out of control, right? So yeah, I can throw some fancy monitor on you, but if it costs $10,000, is it question mark worth it? I don't know.